Hey everyone, welcome back. Today we're tackling an e-commerce backend challenge on Develow.com, fixing an exploited promo code system. Imagine a shopper, stacks save 10 and 5 off, draining their cart total down to 0. Or worse, a negative number where you owe them money. In this video, we're going to dive into our workspace using the Develow IDE. We'll leverage the built-in DVL AI chat to demonstrate some strong prompt engineering, map out the codebase, and rewrite the checkout logic to strictly enforce our business rules. Let's get started. When you're working on a challenge or in a technical interview on Develow, interviewers aren't just looking at your code, they are monitoring your prompt engineering skills inside the DVL AI chat. Instead of blind guessing, we want to use the AI strategically to explore the project structure first. Watch how I prompt the DVL AI to get my bearings. First, I'll type, "Hey, DVL, help me find the data models and state management for this cart application." DVL points us directly to the store configuration. Next, we need to know how the server handles requests, so we prompt, "Where are the API routes defined for applying promos?" Finally, before writing any code, we must understand our boundaries. We ask DVL, what do the tests look like in tests/stacking.test.js, and what specific edge cases are they asserting? By prompt engineering our way through the discovery phase, we now have a perfect map of the architecture without hunting through directories. Thanks to our DVL AI deep dive, the business logic rules we need to enforce are crystal clear. The most recent rule: if a user applies multiple money-off discounts, like a flat $10 off and a 15% discount, only the last one they applied should count. The older ones are ignored. The free shipping exception: a free shipping code, free ship, is allowed to stack on top of that single active money-off discount. The no negative totals rule: the total discount can never exceed the cart's subtotal. We can't have a negative balance. Now let's implement this inside API/src/store.js. We want a clean, surgical 11-line modification to fix the buggy, runaway accumulation logic. First, we look at state.applied promos, which tracks codes chronologically. Instead of looping through all of them and blindly summing them up, we isolate the money-off promotions. We filter the array to grab only the promos where the type is % or fixed. Because JavaScript arrays maintain insertion order, the most recently added promo is always at the very end of this filtered list. We isolate it cleanly using moneyoffs open bracket, moneyoffs.length, -1 close bracket, and store it in a variable called active. If an active moneyoff promo exists, we calculate its value. If it's a percentage, we compute it against the subtotal and round it. If it's fixed, we apply it directly. This completely neutralizes any older money-off codes. Next, we handle the boundary constraint. We clamp the discount using math.mine open parenthesis, discount comma, subtotal close parenthesis. This ensures that even if a promo offers $50 off a $40 cart, the discount stops exactly at the subtotal. Finally, we handle free shipping independently. We use JavaScript's .sum method to check if any promo in the stack is a free ship type. If true, the shipping cost drops to 0, allowing it to elegantly stack with our single active money-off promo. Let's open our terminal right here in the Develow IDE and run the test suite to verify our logic holds up against the automated evaluation. We run our Docker Compose script, and look at that. Beautiful green check marks across the board. Every single stacking test passes seamlessly. Mastering backend constraints like this is all about understanding state order. And remember, when you're working on Develow solutions, treating the DVL AI chat as an interactive structural guide is the best way to showcase your prompt engineering skills to potential employers. See you next time.